Kia ora, Year 9. This video is going to go through some relational skills to do with perimeters, circumferences and areas. So in this video I'm going to assume that you've watched the first one on how to find the circumference of a circle, which we can get from either c equals 2 pi r or c is equal to pi times the diameter, and that you're also comfortable with finding the area of a circle, which is pi r squared. So in that first video, I talked about how when we're dealing with the outside of a circle, we call it the circumference. So some of you are probably going, well, how come she's talking about the perimeter again when we're dealing with circles? The answer is it doesn't matter too much. It should be clear from the context. But I'm calling it the perimeter here because for each of these shapes, I've got to deal with two bits. I've got a circly bit, and then I've also got these straight bits. And the biggest mistakes people make when they're starting to think about perimeter of these shapes is to forget about these bits here. So I'm just going to give you some extra numbers on these, and then I want you to pause the video and check that you already have these formulae down in your book, and then I want you to try and work these problems out for yourself before I work through them. So in this one here, we're going to assume that this is a right angle and that this length here is 5 centimeters, and that here, this length here, this diameter, is 12 meters. And in this last one, and also, so we're assuming here that we've got a semicircle, right? We've got 180 degrees there. This last one here, I want you to generalize what you did up here for this harder problem down here. So let's assume that that angle is 123 degrees. So give those a go. For each shape, I want you to find the perimeter and the area. So have a go and then unpause the video. Okay, so I'm going to work through the blue one first. So with this blue one, if this is 90 degrees, that means that I've got 3/4 of the circle left. So we'll do the area first. So the area is simply going to be 3/4 of pi times 5 squared, right? It really is that easy. We find what fraction of the circle is left, and then we work it out. So that gives me 75 over 4 times pi, which is 58.90486, blah, blah, blah. Remember, this pi number you're using on your calculator, you're not going to use anything crazy like just 3.1 or 3 or 3.14, right? So we round that now to something sensible, and I'm going to go to 58.9 centimeters squared. Now I'm choosing 58.9 to go 1 decimal place more than I have with the 5, right? Okay, so that's the area. Now what about the perimeter? Well, for the perimeter, I have to work out these things. Let's just clean this up a bit. We don't care about the area anymore. So there are going to be 3 bits that go into this, or kind of 2. The first bit is the circly outside bit, and that's going to be 3/4 of the whole circumference. And then the second bit is going to be that straight bit there, and that straight bit there. So, let's shrink that a little bit. What do we get? So the perimeter will be 3/4 of the whole perimeter, which is 2 times pi times 5. So 2 pi r, plus this straight bit and this straight bit. So plus 5 plus 5. So cleaning that up gives me this. We've got 3/4 times 2 times 5. So that's 30 over 4 times pi. Hopefully you're seeing how useful your fractions work from last year and this year have been. So 30 over 4 pi times pi plus 10. So that's 7.5 times pi. What does that give us? Let's see. So it gives us a number with lots of decimal places, but it rounds just to 33.6 centimeters, right? And we'll state that we've rounded that to 1 dp. I should have said that up there too. Always say how much you're rounding something. So that's the perimeter of that one. So now this next problem should be pretty easy. It's quite similar to that one. The only difference is that I've given you a diameter. So for the area of this, it's going to be half the area of that circle. And we need to have, for the area of a circle, the radius, not the diameter. So it's going to be r is equal to 6 meters. So for this semicircle shape, the area will be 1/2 times pi times r squared, 1/2 times pi times 6 squared. That works out to be half of 3618 pi, which is 56.5 meters squared. Okay, what about the perimeter? Well, again, it will be the fraction we've got, so a half of the whole perimeter plus the 12. So the perimeter will be 1/2 of pi times d plus the diameter. It's 1/2 because I've got a semicircle. So it's 1/2 times pi times 12 plus 12, giving me 6 pi plus 12, which gives me, so out of the calculator first, 30.84956, blah, 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 30.9 meters rounded to 1 decimal place. So notice that I'm rounding, I'm stating how much I round, and I'm always giving units. Perimeter is a length, so my units have to be a measure of length. Let's do the area now. Oh, we've done the area, right? So the area was really easy. It's just half of the whole thing. Let's look now at this last one and just have a think about how we're going to do that. What makes it harder is that I've told you that this angle here, just a sec, this angle here is 123 degrees. So what we have to think about is what fraction of the circle that is. So it's 123 out of 360. And that's the approach that we're going to take for finding the area. So the area is going to be 123 divided by 360 times pi, and I have completely forgotten to tell you what the radius is. So let's assume that the radius is a really simple 10 meters. So the radius is 10 meters, so it's going to be 123 times pi times 10 squared. Okay, let's go through all of that. Chuck that into your calculator, and I got out 107.3 meters squared. So there we go. That's that one. And to do the perimeter, as usual, it's going to be this fraction of the whole circumference, right, plus this side and this side. Right, we'll get rid of that big mess now. So the circumference here is going to have that 123 out of 360 fraction. So C is going to equal the two straight sides, 10 plus 10 plus 123 out of 360 times 2 times pi times 10. So that's 20 plus 20 pi times the fraction. And when we chug that into our calculator, what do we get? Let's see. Well, I ended up with 41.5 meters to 1 decimal place. Let's see if that's about right. Well, we've got 20 here, and we know in my head roughly that 20 times pi is around 60 something. Okay, and then it's about a third of that. So it looks like it's going to be 20 plus a little bit more than 60 times a third. So that answer looks spot on. All right, the work on this, there's some work on Dr. Frost, which is really nice for individual skill work, but there is also a very nice worksheet on Maths for Everyone, and the link to that is in your, it's in your skills list, and it's also going to be up on Google Classroom. Thanks for watching, and let me know if you've got any questions.